Hey boys and girls! I hope you are doing really good today. Remember that I miss you every day and I always think of you. Today we're going to be doing lesson 25. And remember, we only have lesson 25 and 26 and we're done with module 7. So for this week, we're only going to do 24, 25, and 26 and we're done. Okay? Now let's go ahead and read lesson 25 objective together. It says, I can draw a line plot to represent a given data set. I can answer questions and draw conclusions based on measurement data. So remember for lesson 24, we learned what a line plot is. So today we're going to continue to do line plots, but now we're going to be able to answer questions and draw some conclusions. You are going to need your workbook and your pencil. Let's go ahead and start with our decomposition tree. Remember we've been using this before. If you don't remember how it looks like to draw it, it's kind of like this. Okay, so you can, what I want you to do is I want you to pause the video, okay, draw your own decomposition tree, and then come back. Okay, now that you drew your decomposition tree, what we're going to do is we're going to break apart 36 into inches on your decomposition tree for 90 seconds. So I need somebody to time you. If you don't have anybody around you to time you, that's okay. You can do it on your own. I want you to try to find as many partners as you can to make 36 inches. I already started and gave you the first example, and that's why I put 30 on one side and 6 on the other. Have fun. I hope you had fun with that decomposition tree. How many could you do? All right, now it's time for our application problem. So if you don't have your workbook yet, go ahead and pause the video, go find your workbook, application problem. Now let's read the application problem together. It says, these are the types of numbers of stamps in Shannon's stamp collection. So as you can see, we have a data table with the type of stamps and the number of stamps. Then it says, her friend Michael gives her some flag stamps. If he gives her 7 fewer flag stamps than birthday and animal stamps together, how many flags does she have? What I want you to do is again pause the video, try to solve this is a 2-step problem. Try to solve the 2-step problem, and when you're done, you can come back. So the problem says, these are the types and numbers. Now we're going to create a line plot showing this data. So for this, you are going to need a paper and your pencil so you can make your number line. Okay, so if you need to pause the video, go ahead and pause it, go find your pencil and a paper, and then you can come back. All right, now let's go ahead and read what the problem tells us. It says, the students in Mr. Shields' science class are growing bean plants. After 5 days, they measured the height of their bean plants in centimeters. The table shows their results. Now, we're going to create a line plot to show this data. What do you need to draw? Can you tell me what you need to draw? Yes, we need to draw a number line, remember, to show the data from the table. Now, let's go ahead and draw our number line. So on your paper, you're going to make your line just like mine. It doesn't have to look perfect. So you're going to do your line just like mine. And now, what number do we put at the very beginning of our number line? Yes, 0. We always start with 0. Now, what is going to be the number, the very first number we're going to start with? Look at your data where it says height of bean plants. Are we going to start with the number 1? No, right? Because there is nothing that says 1 centimeters. What is the number we're going to start with? 9. So we're going to start with the number 9, and because of that, we need to remember to put our slashes, because those slashes remind us that there's no data information before the 9. So we start slashes, we put 9, and what number are we going to stop at? Yes, 15. So we're going to put 9 and go all the way to 15. If you need to pause the video and then press play, you can, if I'm going too fast for you, okay? So 10, 11, 12, 13, 14, and 15. And it's okay if you have space left. Now that we have our number line, what is the next thing we need to add to it? Remember, our line plot needs to have three things. The number line. What is the other thing we need? The title. That is correct. So for this number line, let's go ahead and label it as bean plant heights. Okay, so bean, oh, you know what? We're going to need space to put our little X's, right? So I'm going to leave some space there and I'm going to try to do it as high as I can. Bean plant height. There we go. There's our label. And we're missing one more thing. Who remembers? Yes, we need to put the unit where we're going to be working with. So in this case, as you can see where it says on your table, where it says height of bean plants, it says centimeters, right? So we can put centimeters here as well because that's what it says on the table. And we need to make sure we put centimeters here as well. Okay, so we have our three things that we need. Our title, our number line, and our unit. Now we're ready to work. So if you want, you can pause the video, go ahead and draw the X's. So remember, for 9 centimeters, there's only one student. So you put 1X. Remember that? So you can pause the video, put the number of students with your X's on your number line, and come back. I'm going to do the same thing. See you soon. Welcome back. And check your work. Here's what you should have. Now, I want you to check and compare your line plot with mine. Okay, so we did everything else together except for our X's. So for 9 centimeters, I put 1X because there was one student. For 10 centimeters, I didn't put anything because there was no students that had the plant that was 10 centimeters. For 11 centimeters, I put 4. For 12, I put 6. For 13, I put 7. For 14, I put 5. And for 15, I put 3. Now we're ready to answer some questions. So the first question I want to ask you is, by looking at your line plot, which bean plant height occurred most often? So looking at here, which one has the most X's? Yes, it's easy to see that between 12 and 13, right? Mostly 13 because 13 had 7 and 12 had 6. So the most would be 13. What is the difference between the tallest and shortest bean plant? Well, the tallest bean plant would be 7 and the shortest bean plant would be 1. So the difference would be what? If the tallest is 7 and the smallest is 1, the difference is 6 centimeters. Yes, how do we know? Because we did our problem. 7 minus 1 equals 6. Very good. Now, how many students are in this science class? So remember, each X is a student. So we would have to add all our X's to figure out how many students this class has. So I want you to pause the video, count your X's to see how many students we have. Add them all together and then come back. Now that you're back, how many students are in this science class? Yes, we have 26 students. 26. Are there any measurements outside the main grouping? So look at the measurements. The main grouping means the most. So here the most that we have are between 11, 12, 13, and 14, right? Because this is where the most of our data is, the main grouping. Do we have measurements outside of that? Yes, right? We have 9 and 15. Why do you think this happened? Why do you think of 9 centimeters, there's only one little plant, and for 15, there's only 3 plants? When these guys in the middle, 11, 12, 13, 14, have more. Why do you think this one only 9? Yeah, I think that student, maybe he wasn't watering the plant enough, right? Or maybe he put too much water so it didn't grow, or maybe he was forgetting to put water, or maybe he didn't put enough dirt. Yeah, and then this one over here, why do you think these guys have 15 centimeters? That's a long plant, right? Yeah, because they were probably putting a lot more water, or enough water, and it was growing just right. Very good. Now, the next one we're going to do another number line. So, Ms. Juarez, it's easy because I can just erase, 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 right? But you need to find another piece of paper so that we can do another line plot. So, again, pause the video. When you're ready, you can come back to do the next one. Let's read our next problem. It says, in gym class, Mrs. Rincon measured the students' flexibility with the sit and stretch test. As you can see in the little picture, they're sitting and stretching. The table shows how far the students were able to reach in centimeters. Now, this is the you do. So I want you to create a line plot to show this data. Now remember the 3 things your line plot needs to have: the number line, the title, and the unit you're measuring in at the bottom. So in this case, it'd be centimeters, so you put centimeters at the bottom. You're going to pause the video, do your whole line plot by yourself, and then come back when you're ready to answer some questions. Welcome back. Here's what you should have. I created my line plot, and I took a picture of it and posted it right here. So if you want, you can pause the video, check your work, and come back. Now that we have our line plot, we are ready to answer some questions. Let's look at it. It says, question number 1 says, how many students were the most flexible? Well, I think the most flexible would be how many? 1, right? Because the one that could stretch the most was 34 centimeters. So it was 1 student that was the most flexible. Next question says, what was the difference between the longest and shortest sit and reach distance, and how do you know? Well, the longest was 34 and the shortest was 22. So we need to find the difference between 34 and 22. So you can start at 22 and count on to 34, or you can do 34 minus 22. So what did you get? 12, right? Because 34 minus 22 equal 12. So the distance is 12 centimeters. How do we know? Because we solved it using a problem. 34 minus 22, or because you counted on, or whatever, however you solved it. Next question. How many distances were reached by only 1 student? How many were reached by only 1 student? 3. 3 were reached by only, oh, actually it's 4. Wait a minute, let me count right. 5 were reached by only 1 student. Which are the distances? 22 only has 1 student. 23 only has 1 student. 25 only has 1 student. 31 only has 1 student. And 34 only has 1 student. So 5 distances were reached by only 1 student. Next question says, how many students can reach farther? Remember, farther means more far. So how many students can reach farther than 28 centimeters? So anything more than 28, we count. So how many students reached 29? 3. How many reached 30? 3. So 3 plus 3 is 6. How many reached 31? 1. So 6 plus 1 is 7. None on 32. None on 33. How many reached 34? 1. So 7 plus 1 is 8. So how many students reached farther than 28 centimeters? 8 students. Very good. Next question. Why aren't 24 centimeters, 32 centimeters, and 33 centimeters listed in my table? So if you look at my table carefully, I did not put anything on 24, 32, and 33. Why do you think that was? Because there were no students that reached those numbers. There was nobody in 24, there was nobody in 32 and 33, and that's why they're blank, right? Okay. What did you do on the line plot? Did you copy all the numbers? Did you put all the numbers on there? Or did you skip those numbers? Because there was none on 32 and 33, did you not put them? You still put them. Very good. Next question. How might this data be different for third graders? You're about to be a third grader, so how do you think your data would be different when you're in third grade? Well, I think you're going to grow, and I think you're going to be able to stretch more. So I think the numbers are going to be bigger because you're going to be able to stretch more. So maybe there's going to be a lot more in the 32, 33, and 34s than there is in the 27, 28, 29, right? Now, the last question says, what can we do to become more flexible? If we do those things, how might our data set change? So what can we do to become more flexible? Maybe we can work a little more, right, in stretching every day, or do it a little more every day. And how do you think our data would change? Ooh, you'd be more like a third grader, huh? Going closer to 33 and 34 instead of being in 25, 26, right? Very good. Well, you did awesome today. Okay, I know that there was a lot of thoughtful responses today, and I feel like you are ready for your problem set. So you're going to do your problem set, and then you're going to do your exit ticket. Okay, if you have any questions or you need help with anything, tell your parents to call me. I'm always here to help you. So let's do the problem set, and then we do the exit ticket, and you're done with lesson 25. See you on the next lesson.